Okay, well, today we're dealing with stone and concrete masonry, kind of a continuation of brick masonry. We're moving on to dealing with stone and concrete. So first of all, stone masonry. So as we look through here, we'll start with just the basics of stone. There are three basic kinds of stone. There's igneous rock, there's sedimentary rock, there's metamorphic rock. In this picture down at the bottom, the three pictures, I've got a picture of granite, limestone, and marble. And they're actually all three the same minerals, lots of silica, but the igneous rock was developed from molten lava, from molten rock in, maybe from volcanoes and that sort of other sources like that of molten rock. Sedimentary rock, well, in Louisiana, we're kind of familiar with the concept of sediment. Well, sediment packed in over the eons becomes rock. And so if we can't find rock very easily around us in Louisiana, but if you were able to dig down thousands of feet below us, you would find the sediment has been turned into shale. And shale is something that is it's a sedimentary rock. So that's a version it's just as limestone is. And then metamorphic rock is where both igneous and sedimentary rock can be reformed under great pressure, usually deep down in the ground. And the metamorphic rock that we come across with generally, like marble, has been pushed up over time from plate tectonics, crushing and pushing up the plates and uplifting rock that would just newly exposed. So that's the best example would be marble. But marble is, but there's there's many other versions of these rocks, but these are good examples of this. And in construction, we use granite, we use marble. Limestone, maybe not so much, but there's I'll just point out a really good, maybe a better example of two rocks that are closely related. Shale, I had mentioned, that's a sedimentary rock. Well, slate is a metamorphic rock. Slate is shale that has gone under a metamorphic process, and so it's a much more compact material. So we're only going to look at this at a light level here, but you want to understand some things about the building materials that we build with in construction. If you ever get a chance to take a kind of an introduction to geology class, I think you'd find it really interesting, and it can help you in some of your construction work to know these properties that I'm going to talk about a little bit. So I'm just giving some examples of the granite group, the limestone group here. Let me back up for a minute and just point out that granite is not anywhere near as porous as limestone. Limestone is more porous. It's going to be sedimentary material. It's going to be, water can soak in through it more. So you wouldn't want to use limestone or shale as a countertop because it's so porous. You'd have to really heavily seal the material with some kind of a synthetic sealer. Marble is actually something that's even more compact and compressed than granite. So it even absorbs water less than granite does. But so granite makes a great countertop, marble even more so. And or for flooring or things that are going to stain. I mean, if you go spill some ketchup on limestone countertop, you're in trouble. Granite, not so much, and marble even less so. So that's an important property when you're talking about the properties of these different rocks, So granite, less porous, limestone, and other materials like that, far more that are sedimentary, would be much more porous and more likely to stain. Quartz is less likely to stain. Slate, less likely to stain. Slate is used for roofing. It's so good at not absorbing water as a metamorphic rock that even though that it comes from a sedimentary rock originally with shale, that it works excellently very, very well as a roofing material, as a roofing shingle or tile. Marble, extremely non-porous, and so it's used in flooring all the time and sometimes countertops and surfaces that you don't want to have the maintenance or the problems of it staining or mold growing. Mold can't easily grow in marble, so it's also used on panels on the outside of high rises and other buildings in businesses as expensive as it is, it's low maintenance, so it just pays for itself over time. Travertine, oh, that's a form of limestone. It's a very porous material. Um, so here we're looking at a quarry. The title page, actually, we were looking at this quarry. If I just maybe skip back to the title page for a second, I know you're looking at what looks kind of like a concrete wall that was formed up. No, that's actually a solid rock wall. It's been cut down, and every line that you see, horizontal line running across there, that's another level that they've been digging, cutting down to cut this stuff. So let me go back to the page I was supposed to be at here. Where is it? Right here. Yeah, we're looking at that same wall off in the distance. These giant chainsaws, and that's basically what they are not like any chainsaw you ever dealt with or I've ever dealt with. It's dealing with, it's cutting rock. And just about any blades that we use to cut through rock or concrete, we cool the blades to keep them from wearing out and burning up with water. You see all this mud around there. They're literally kind of keeping everything inundated in mud to kind of keep it from overheating the blades. And they're just steadily cutting deep cuts, maybe 6 feet down, 5 feet down, I'm not sure, somewhere in that neighborhood, all the way across the field. And they might even set those rails up and run the other direction and do the same thing and just slice and dice this whole field of rock. It's all solid rock below them, so they're just cutting across. It's not gravel, it's just solid rock that they're cutting through here. Sometimes they'll take bladders and stick them down into the cracks to and inflate them in order to break the blocks loose from the bottom afterwards, because they've cut them on all four sides maybe, but they got to break the bottom, and then sometimes there's cruder things that might go on. Here they've got a series of holes they're putting wedges into and maybe break it. There's other ways, but most commonly you're going to be doing it, with these something like a big saw like this. And there's other kinds of ways of cutting through rock with high pressure water or fluids sometimes. So there's other ways. But anyway, but the ultimate goal is what you see in that picture that I've got right to the extreme right on this page, where you've got a pile of big blocks. There might be 5 foot by 5 foot by 16 foot long chunks of rock, cubes or rectangles of rock. And so from there, then they can slice and dice them. So up here in this upper picture on this page, they're literally slicing through and making rock panels that might be only a couple inches in thickness. Some of them more. This one looks like it might be a little thicker than a couple inches, but I'm not sure. There's no banana for scale here. But anyways, so we use some of the similar kinds of tools for cutting rock and stone as we cut wood with. Of course, different blades and different setups, completely different equipment, but it's the same concept of having table saws, regular arm saws, band saws, all of that at an industrial level. Of course, it's a whole different thing. Here, they're literally got a shaper that's actually running through and shaping some detail that might be some kind of a stone piece that might be going across the top of a building, or who knows. And of course, they charge a lot of money for these things. It's not the kind of thing just anybody can do. And here there's some more artistic work, maybe for a corner piece or something. There's a lot to be desired here as far as safety goes. They don't have, there's a lot of things. No gloves, no eye protection. They just wear a hard hat. It makes them look official, but that's not really stopping anything from hurting them, like the dust from the silica. There's so much going wrong here. Anyways, they're artists, so you never know. Maybe that's why, but still, no oversight, safety-wise. This table is kind of describing what I was talking about in the second column on this table at the bottom, what I was talking about as far as porosity, water absorption by weight maximum. So you see that the percentage of water that would absorb by weight in the granite is like 0.4%, not even 1%. Meanwhile, the limestone, somewhere it depends on the source of the limestone. In other words, there's a lot of variations in versions of limestone, but 3 to 12%. So even at 3%, it's many orders of magnitude more absorbent than the granite. And if you get it to 12%, it's extremely absorbent. Sandstone, similar, 1 to 8. So, sandstone may be a little better than limestone, I guess, but still, similar concept. very porous, a lot more likely to stain. Marble is half the water absorption of the granite. So, 0.4% seem pretty low. 0.2% is half of that. So you get the idea of the properties here, and that's one property. The density has to do with how much it weighs per cubic foot. Granite's pretty darn heavy, heavier than concrete. Marble can be as heavy as concrete, or some sources can be just as heavy as granite. Whereas you see some of the sources of limestone are much, much lighter. I would suggest that probably if you got 110 pounds per cubic foot limestone, that's probably the 12% porosity, same thing, so, these are things you can talk about, the compressive strength of the granite or of the limestone or the sandstone. And as you see, the limestone and sandstone, it just depends on the source, because it just depends what it's been through and how much time and compression it's been under. So when it comes to compressive strength, the granite is kind of the king, consistent king anyways, whereas, as far as compressive strength, much, much stronger than concrete, or most concrete. There are some advanced high strength, super high strength concrete, or what we call ultra high strength concrete, that could be in that neighborhood of 19,000 or 20,000 pounds. But most concrete is going to be somewhere around, 4,000, unless you got high strength concrete for bridge girders and stuff. They might be in the 6,000 or 7,000 psi mostly. So I'm looking over on the fourth column, I guess, there. But they don't have much tensile strength, not much to speak of. So the tensile strength is kind of measured in the last two columns, modulus of rupture minimum and the flexural strength minimum. Those are kind of dealing with tensile strength. And you see those numbers are pretty low in general. Okay, just an interesting thing. I'm not going to be making you memorize any of these numbers, but I just wanted you to know that these are the kind of properties of these stones that make you choose a particular kind of stone for the work you're doing, Just get a little sip of coffee here. Let's see. So one example on the side of buildings, they might have some of those panels cut and polished and smooth, like to make them smooth as possible so they're even less porous and less likely to hold water or mold or other things, birds and critters and everything else. Hard for critters to make a nest on a super smooth surface. Not impossible. As we know in Louisiana, they're particularly industrious. So in this picture, this photograph on this page, there is there's a kind of a panel, a couple of panels here you can see that are literally bolted to the wall. They're bolted to angle iron, and the angle iron is bolted to a wall. And so they had to put a super duper membrane up. They end up with a cavity wall, a cavity behind the panels, so that any moisture that condenses behind there can weep out, just like you would behind a brick veneer wall around a typical house, where you've got a cavity in there too. It's done in a similar way, and the angle iron is purposely set up the way that it is, where the leg is down at the bottom, so that there's no place for water to collect and it can dribble out and that sort of thing. It's all about shedding the water back out and still having a nice durable surface here. And these things have to be secured well enough so that there's no chance that these panels are going to come off. They're really going to ruin your day if one of those those panels of rock come down on your shoulder when you're walking on the sidewalk below. Stone masonry in other fashions, this is what we call dry stack, and I was searching for that term back in chapter 8, and I just forgot it for the moment when I was in the heat of battle, but on the earlier video. But stone masonry, if it's dry stack, it looks, not as junky as this. They've got some kind of concrete chunks down here they're using. Possibly that will be hidden, and that's why they're able to use it there. But in building walls dry stack, any kind of dry stack walls or columns or anything else, you just don't see any mortar. There can be mortar, but a lot of times in modern construction, it's not mortar anymore. They found it's much more effective and more reliable to use construction adhesive. In other words, you can glue rocks together, and literally they'll hold together quite reliably. And so our glues are just so much better than anything we had 50 years ago. That's kind of a relatively new thing, a new concept. But so you can go to restaurants and find rock walls that show no mortar, and there isn't any mortar. It's probably glue. the early Romans, sorry, Romans, the Egyptians, yeah, sorry, yeah, I got the wrong group here. The Egyptians with their pyramids, those were rocks with no mortar, no glue. They weren't when they kind of glue, but their principle was they were using such massive rock that the friction was incredible, and the friction on a very massive piece of rock can also be a. And I built rock walls where there was no mortar, no glue, but it had to do with the weight of the rocks. Not they were not the size of the pyramids by any means, but they were heavy enough. But typically, then we put them at an angle, maybe a 7-degree angle or maybe 10-degree angle, sloping away from you, as you go higher. And that helps with the stability of a rock wall like this. Now, this other diagram here on this page is up in the top right corner, is showing you a concrete masonry block wall is the main structural wall in behind. And then on the front side, on the side we're on, we're looking at that drawing or that diagram, and it's showing stone, probably marble. That's what I've normally seen in this, where they've had cut stone that is stacked. It's got grooves and stuff, and it's held in place. Besides its weight and in the grooves and everything, it's held with clips that are laid into the mortar of the concrete block wall, and then those clips come off to hold this stone wall. So it's kind of physically held in place. You might not use something like that for a high rise. You might have to use a little bit more reliable system because you don't want any of this stuff falling. But generally on a 1-story, maybe even a 2-story building, you can get away with something like that. And it's basically another version of what we call a cavity wall. There's a cavity between the walls, and that allows the air and moisture to condense and collect and dribble out through weep holes down at the bottom area. Okay. Now, there's a couple of concepts or terms I want you to get straight here. First one is rubble. You see this wall picture we have up top? It's random pieces of of rock that are fit together like a bunch of puzzle pieces. Now, the reality is when you get a bunch of rocks on site, there is no picture you're going by. You just have to creatively find the rock that's the right size to fit in the spot that you're going. And so it takes more labor because it's a bit of artistic expression, a little bit of puzzle laying, as opposed to taking very regular shaped stones that are cut and putting in place. So rubble refers to this irregular shaped rock when you're making a wall out of irregularly shaped stones or blocks. Now, the next page, I'm looking at something that's all 90-degree cuts. They're all 90-degree shapes. So that we call ashlar. I used to think ashlar was some special kind of stone, but no, it only has to do with the fact of how it's cut. And so if you got 90-degree cuts on your stone, it's called ashlar. So now I'm backing up to the other page again. So on the rubble, you see two different versions. One that's considered coursed, where they've literally got nice little straight lines every so often. So they had to cut some of this rock in order to do that, but they're getting coursed rubble. The rubble means it's not square stuff, but some of it is in the coursed, whereas the random rubble, there ain't any pattern to it at all. It's all completely artistic, like the picture we have here. So there's a difference between random rubble and coursed rubble, but that's kind of just extra stuff. I'm not going to be testing you on that. I want you to know the term rubble. Rubble means it's irregular shaped stones, and that's there, as opposed to this other second picture, ashlar, which is square shaped, square cut stones. Now, within the drawings down at the bottom, they've got random ashlar and coursed ashlar. Yeah, so they're all square cuts, so, but there are, so there's variations on a theme here. But as long as you know rubble is irregular, whereas ashlar is square cut, you'll be fine with any test questions that I've got. I just want you to understand some of this because it can come up. These kind of terms can show up on your specifications of a drawing and that you're bidding a job on. Is if you don't know these terms, your eyes will glaze over and you'll miss it and you'll misunderstand. The labor will be higher in the rubble, whereas the ashlar will be higher cost in the materials. And I'm not sure that they balance out or not. But these are important considerations when you're bidding a job or your subcontractor is bidding a job. You got to make sure they're aware of it. or you underbid a job if you miss things like that. And then you cost your company a lot of money. It's embarrassing. You feel bad, and you might not work there anymore after a while if you keep doing things like that. Okay, I don't mean to scare you. Okay. Now we're moving on to concrete masonry. So concrete masonry, we're talking about human-made blocks, right? They're not something we mine out of a hillside like rock, and they aren't made the way brick is made. Not really. They're made out of concrete. These are concrete bricks. We don't call them bricks usually. They're called them blocks. So these blocks normally are, we label them as concrete masonry units. That's the official term for these blocks. Now, some people, especially down here, I don't think I heard the term so much until I got here in Louisiana, but call them cinder blocks. And it's true that some of these blocks were made with coal ash cinder, I guess, coal ash cinder, as the workability agent instead of using much of the hydrated lime. So in that sense, there's, that's a truth, but that's not what we call them in construction. They're not likely to ever see cinder block listed on a drawing specification or anything like that. Anyways, this particular picture, before I left this page, I wanted to show you or point out that these blocks are not the plain vanilla boring masonry blocks. These are what we call split base blocks. They actually make them is a double wide, like a trader, double wide trader. No. Two blocks twice as wide as the block they want, and they have a big wedge and they break it in half. They literally split it like an axe, on a very heavy duty axe on a hydraulic system that breaks that block into two pieces. And so you get this irregular shape that makes it look a little bit like rock. If you got to, especially when it first came out, boy, everybody was all excited about it. The first time I think I saw split base masonry block was in the mid 70s, and I think it'd been around before that, but it was pretty new, at least in our area. It's been around a long time. It's not a brand new technology, let's put it that way. So the split face block. Now, I'll show you some examples of block products here in here. But we call these CMUs. It's the three letters CMU for concrete masonry unit. So you want to make sure you know those abbreviations, because you could get a test question where that shows up and you need to know what it means, or else you're going to misunderstand what the question's about, maybe. Okay, so yes, people have made individual blocks on their own. And this is something out of I think a Simpson or a Sears and Roebuck's catalog. In Canada, we call it Simpson Sears, and down here in the States, it was Sears and Roebuck or whatever. Roebuck. Anyways, I don't think Sears even quite exists quite the way it did, if at all, anymore. But anyways, it was the equivalent in the 50s and 60s, if not the 30s and 40s, maybe, of Amazon, where you order stuff, except it was all through the mail or through eventually their own network. Okay, I digress. So yes, this is a fancy one where you could make these blocks, but the whole idea is that you make a block with zero slump concrete, meaning only enough water for the chemical reaction. So it's such a thick concrete mix. When you fill the form with the block, the concrete, and then they take apart the form around it and leave the block to cure, and it can stand freestanding all on its own without a form right away. You don't have to wait any time. Once you've got it all in the form and it's all compacted, you pull the form away and then you can go make another one with the form, kind of thing. And that's still the basic principle of modern concrete masonry blocks. It's just that now they have machines that are doing this instead of people doing all of this. And the block form that we had, just for the fun of it, not that we made a lot of blocks out of it, but when you have a little leftover concrete, sometimes somebody would go and make a few blocks. It was nothing this fancy. It was something that was just a form that you pick up off the bench and sit down next to it on a sheet of plywood, then make a few blocks on the sheet of plywood, kind of thing. But in modern times, I guess I need some good pictures of it. Modern times, this is showing the tail end of a concrete masonry block factory, concrete masonry unit factory, where they run these, when they're standing up, they can dry out. And so they run them in steam autoclaves. that are actually accelerate the curing and keep the concrete from drying out. They don't literally heat the stuff, overheat it. You don't want to overheat the concrete, but the steam is allowed to become super humid rooms or spaces, or what they end up with in the end. So there's lots of different shapes and styles of concrete masonry blocks out there, but by far the most common one would be the standard one that I've got, the first bullet at the top of this page. The standard block is the nominal dimension, the rounded up dimension, is 8 inches by 8 inches by 16 inches. So 8 by 8 by 16. So you should know that. I've got an asterisk on there because you need to know that standard masonry block dimension. Now the reality is, if you actually take a measuring tape to the block, that's where the second bullet is about. And I want you to know those dimensions too. The actual size is, instead of 8 by 8 by 16, it's 3/8 of an inch less than each of those dimensions. So the actual size is 7 5/8 by 7 5/8 by 15 5/8. And they're pretty reliably that. So the theory is, or the logic here is, that the nominal number is the installed dimension, including the mortar, and the actual size of the block is 3/8 of an inch less than that, because when the mortar joint is supposed to be, and it's extremely reliably, 3/8 of an inch in a concrete masonry unit wall. A CMU wall, or a concrete masonry block wall, the width of the mortar joints is very reliably going to be 3/8 of an inch. So that when you've got it installed, you've got every 8 inches in height, from the center of one mortar joint to the center of the next mortar joint is 8 inches, or from the top of the block to the top of the next block, whatever you measure from. And so we want that. And then the same thing, it's 15 5/8, but installed on the wall from center to center of the joint. The length, the width, or whatever you want to call it, the horizontal dimension of that block installed in the wall is going to be 16 inches. So it's just, these are important numbers for you to know. So if you remember the 8 by 8 by 16, that'll help you with understanding the other numbers, because the other numbers are just 3/8 of an inch less than that. So they're going to always be 7 5/8 by 7 5/8 by 15 5/8. You're just dropping the number down and using 5/8 of an inch. So it's not like you have to do the math per se, but it does help you remember what you got to remember in there, in that front, in dealing with that. Okay, and again, the concrete masonry units, there it is in writing up at the very top, right underneath concrete masonry in black. You've got that larger font at the top. So we will have a math question or two on your exam number 3, where you are, unless you're in the summer class, where we deal with calculating how many concrete masonry blocks in a wall. And it basically means, well, what we do is we figure out what the total square foot area of one side of that wall is, the total square feet of that wall on one side, and we divide by the area in square feet of one block installed, the nominal dimension. And by dividing by the area, divide the area of the wall by the area of the block, that'll tell you how many blocks, basically. That's how we do the math, or one of the ways. You can also flip it around another way, how many blocks per square foot, and that's another technique. But it's the same concept anyways, either way. So, okay, we won't worry about that here, though. Here's a few more pictures of our artistic picture of a bunch of other blocks. Maybe the one right on the very right-hand side is a standard concrete masonry block. It's a 16-inch block, what we call a 16-inch concrete masonry block, the standard size, 8 by 8 by 16. So there's also different weight categories of concrete masonry units here. There's basically the normal or heavy weight, depending on perspectives. There's the medium weight and the light weight. So it's kind of like boxing. Well, no, nothing like boxing, but you get the idea. So in construction, if you're talking about structural walls, they generally are going to be normal weight concrete, or what they're calling heavyweight sometimes. So that's basically some are close to 40 pounds per block. So it's a significant weight to those blocks. You really will see the difference, because you get to the medium weight and you're looking more like about 30 pounds per block, and the lightweight can be down to maybe even 20 pounds a block. So what's the difference? It has to do with the aggregates, because the concrete that they make these blocks out of, they use pea gravel for the largest aggregate size probably in the concrete, I would say. Yeah, maybe up to ½ inch. Pea gravel is considered kind of 3/8 of an inch or ½ inch, somewhere in that area for the size of the rock. So bigger than sand particles, but anyways, with by the time you get to the medium weight and lightweight, you're starting to use a human-made little gravel aggregate that is basically made with machines where they heat it up like popcorn, taking pozzolans and other kinds of product to make vermiculite and all kinds of other things. So they're making a lightweight block, and it's often used in garden centers. So you go to Home Depot to the garden center to buy block, and sometimes the block it's in the garden center is that they might buy is lighter, and it makes it easier for somebody who's not particularly strong to pick it up and take it home for gardening or something, you know. Whereas in construction, on construction jobs, it's far more likely that they're going to be sticking with normal weight, because it's so much stronger, and so you need that strength. There's no rebar, there's no mesh in these concrete blocks, and so they are still very fragile. You drop them, you bang them with a board or a hammer or something, they're going to crack, you know. Now we're laying out the blocks just like when we were talking about the brick. We tend to build the buildings when we're involved in general in construction, but particularly when we're dealing with masonry and brick, in 8-inch units. So all the windows and doors and the lengths of walls generally are some unit of 8 inches. It's just very, very common to do that, because otherwise you raise your costs when you have to cut a whole bunch of blocks. You know, they make half blocks, and they can cut some half blocks fairly easily on the job site too, but they'll have a saw for that. But you start making something some oddball dimension, you start making masons spend a lot more time to make these dimensions work. And it's true with brick, it's true with block, and so that's an important thing. Looking at this picture right here, the space between the window and the door on the left-hand side here of this picture is 2 feet, and I didn't measure it. I'm just saying I can see that it's basically a block and a half wide. Well, a block and a half, you know, that are 16 inches times 1.5, that gives you your 2 feet basically. Over and over on the right-hand side, that's basically 32 inches. It's 2 blocks wide. You see it's 2 blocks wide, and then you also see it's a 1 block, and other layers, other courses, the course above it, you'll see 1 full 16-inch block with 2 half blocks on each side, was still basically 32 inches. So this is how we build. You don't just randomly pick these dimensions. We pick dimensions that work, and we choose them when we're building, when we're choosing what size of doors to use, what size of windows to use that are going to be in these walls. We don't just do it randomly. We do it with purpose, and that generally means some kind of 8-inch increment on the dimensions. So that window and that door would have a width that is divisible by 8 inches, basically, in the rough opening. They're, of course, establishing the corners just like they do with the brick, and so you get the best, most efficient, wisest, most experienced mason establishing those corners, and then the flunkies can kind of fill in the middle. The other thing is that concrete masonry block walls are mostly structural. They're usually not that pretty. I mean, the split face block helps to make them prettier, and there's rib face split face block too, and there's other versions. There's other ways you can have nicer concrete masonry block with ceramic tiles infused into them and that sort of thing. But these are always pretty much structural building. You don't make a structural wall by just having a bunch of blocks and mortar. You've got to have the concrete and rebar columns hidden inside them. So these cells are filled, maybe not every single one, maybe every other one or something, filled with concrete and rebar. So you have rebar coming out of the foundation, then you splice some more rebar on all the way up inside here, and then you fill these these cells all the way up with concrete. And that gives you these hidden concrete columns bonded to the walls, hidden inside these walls. And it's not just columns. We also have hidden beams. So come and take a look. Well, first of all, I got this picture, I forgot. This is showing mesh that's laid into the mortar along with those columns. The mesh by itself is not equivalent to having a proper beam hidden in that wall. It's nothing wrong with doing it, but it's not good enough by itself. That's not adequate. But here we go. This is showing you one way to do it, and that is, so these horizontal beams that are hidden inside, we fill and pour concrete there with the horizontal steel. We're making a beam hidden in the wall. Now this is a little unusual. We got a bond beam down at the bottom. It's right near the bottom. Generally, the first bond beam in a wall is usually about 8 feet up, maybe over top of the windows and doors. If you've got windows and doors in the wall, about every 8 feet up a wall, and up at the very top of the wall, you will always have a bond beam. So this one here, they were able to cut halfway through the blocks so that the block still holds together, and then they're ready to pour a beam. That's basically going to be like a 4-inch beam. They might even cut the block above and have it make it taller that way. What's more common in commercial jobs, or jobs, big commercial jobs anyways, is to buy special blocks that are already U-shaped, that are, when you're looking down the barrel of the block, you're looking at a U. And so you have this hidden path that's much deeper, that's maybe 6.5 inches of that they can make a 6.5-inch deep beam through, and then they'll chair the steel up in it and that sort of thing. Okay, so that's a bond beam. Here's another version of a variation on a theme, but this is more about, they've cut this block so that they can deal with pouring a concrete slab that'll sit right and cast in place, but sit right on top of here, or maybe fill the concrete in here in order to actually have a ledge for precast concrete parts to be sitting on that ledge. So they cut it a little different. Here's an example of a bond beam that's precast concrete that's being tied to a wall in the foreground and also one in the background that we don't see. And so that picture is showing another way that you can connect from your bond beam across and still span over an opening of some kind. So that's one method. When you've got a support over top of doorways and over top of windows, you've got to build a header of some kind. Remember, a header is just a beam. Well, over on this diagram on the right-hand side of this page, we're looking at an I-beam where they cut the top flange short, and the bottom flange they've left large so it could be a shelf for to wrap the block on. And so they've got concrete masonry blocks, concrete masonry units, narrow ones on each side. So they're literally wrapping the beam for aesthetics, for the looks. But the real beam here that's supporting the weight is that I-beam of steel. Whereas down the second one down, you're actually looking at where they've had to build some kind of a structure, maybe out of steel or wood temporarily, to hold up that block in midair, the blocks in midair for a beam, and they can put bond beams, and those are the U-shaped blocks I was talking about. You kind of see from here. They would, so that you can pour your concrete. And once the concrete is set up, then they can pull that temporary stuff out from underneath it. And in the very bottom picture, they've got a precast beam that's already been made, pre-made ahead of time, and they put that up and sit it up over top. So that's more like what you see in the photograph in that sense. Not quite the same thing, but similar concept. Precast items being used. So there's different ways of spanning over top of windows and doors, but there's just examples, just to kind of open up your eyes to what goes on here in this business. Now, I showed you the split face before. This is a close-up of probably the same wall. It looks to me like they have stained this wall with some kind of a stain that's soaking into the block wall, and maybe even sealing it too, to keep mold from growing in it, keep making it. So maybe some of these stains are kind of somewhere between a stain and a sealer and paint, and so it still isn't coating it so badly that it doesn't look like stone, or maybe so I don't know. It all depends on the perspective of and the colors that you choose. There's other ways to do this, but that's an example. But this is a split face, what I call split face, but it's really full split face, I guess is probably more of a correct term. This next picture is showing you another kind of split face. This one actually came out first, as far as I can tell, and it looks like a whole bunch of vertical brick, but it's actually a whole bunch of masonry blocks that are not vertical at all. It's the front face of the bricks just has these ribs. So they call it rib split face. So it's still split face, but it's got ribs in it. And they became zones of weakness that made it easier for them to split these things back in the day. And of course, the machines have gotten fancier since then. There's another kind of block where you can pay a lot more money for this, where it's been ground. A ground face instead of split face has been ground. They're literally polishing it like rock to get this look. Now you see black colors in here. That would probably be another level of specialty where they probably added to the concrete mix some carbon-based material. So you in other words, if you put special rock in there, into the concrete mix, when you grind it, you get a special look. And so that's the other kinds of tricks that can be done with. There's so much that can be done with specialized concrete to get certain looks with concrete countertops and everything else. And then we've got, well, you've probably seen or heard of or watched it on TV, glass block. The glass block is kind of an old-fashioned idea, but it was a way to lay in these blocks to get some light in when you maybe didn't care about having a real window. And sometimes it was used as room dividers and stuff too. So that's a thing. And then you're seeing this ceramic tile here on these blocks for looks like primary colors for almost for a elementary school or something. But I got some better pictures of ceramic tile showing in better examples from the old, the Jefferson Highway, Goodwood, I think they call it the Goodwood clay, I don't know. At the corner of Jefferson, Claycut, and Goodwood, right near the college, they've got quite a fancy fire station here that when they were building it, I was able to get on the job and take pictures of these blocks. So these are some of these blocks, like the upper right corner picture, you're looking at blocks that are not 8 inches wide. Those are, the thickness of the wall, the depth of that wall is going to be 1 foot instead of 8 inches. So those are those are deeper walls. And they had a reason for that. The same thing in this picture here. The lower picture, well, my cursor doesn't work in here, but that block that is on the left, bottom left, is a double wide bond block. So it's got 2 troughs in it that they're going to make into beams on there. And so that one I think is actually, I guess it's still 12 inches wide, 12 inches for the depth of it, or the thickness of the wall, basically, where, of course, the ceramic tile is going to be on the exposed side. And then one more picture. I've got 3 pictures on this thing. The bottom right corner picture, you're looking at a block it's U-shaped, but it's tall. The U is a much taller. It's a 16-inch tall bond block. And so they literally take that 8 by 16 inch, 8 by 16 inch, I'm not trying to figure out if it's 8 inches. I think so. 8 by 16 inch block, and they're standing it up vertically to make a much stronger bond beam at the very top of the wall is where they placed them. So I've got pictures of this. Now, first of all, back in chapter 6, I think it was. Yeah, I was showing you a picture of a mock-up of a doghouse that had copper gutters. So you can have jobs where mock-ups are required or in the specifications, and if you miss that, then that's going to cost you a bunch of money too. Well, this is a better example of a mock-up because in commercial work, mock-ups are much more common where an architect will require it, and it all has to do with the architect or the engineer wanting to make sure you're going to construct these walls correctly the way they're supposed to be done. And so it had to do with where the waterproofing goes, what kind of space, which kind of rock, how the stone will be installed or the brick. And what you're looking at here in the picture, the first one that's closest to us on the right is a brick wall, and it's got a space between the wall, about a 4-inch space. You can see the waterproofing on the concrete masonry block wall, the concrete masonry unit wall. And then the next wall over, sample wall mock-up, is looking moving toward the left, is those are marble stones. Those are cut marble pieces that are being held in place. And so it's everything about the brick ties too, and how the ties tie from one wall to the other, from mortar joint to mortar joint, and that sort of thing. The third section over there, it's set back because they've got that's the ceramic tile blocks that we were looking at. You see how they're laying them. They get installed when the same time they're installing the block, they're also installing the tile because it's already fused to the blocks, and so it's a nice idea. And then you're seeing, so my point is just that this is the mock-up is this is a much better example of a mock-up for you to understand. It costs money to build that thing, and that thing was taken down afterwards, right? After they finished everything else, they got this to refer to the whole time they're building all those walls in the background. But eventually this stuff isn't sitting there anymore. They took it down. So it cost money to set it up. It had to be approved by the architect or the engineer, whoever was requiring it. And then finally, when they're done, all that can be removed. So that ceramic tile is right here, and this is inside the garage bays where the fire trucks are parked. And you see right at the very, very top, we've got that tall bond beam installed, where you've got the 16-inch block standing upright with the deep bond beam. This a 16-inch tall bond beam, basically. The other thing over at the corner they don't have a roof on here yet, but those columns that are right by the door, defining the door, in fact, they've got like a 16-inch by 16-inch blocks there with some heavy rebar inside them in concrete. Because if the fire truck hits that could be bad. So they made those things stronger so that the fire truck, even if a fire truck hits it, that sucker's going to stay up there. One other thing I could mention before I leave, and I'm getting into details, I guess, overdoing it here, and that is that those doorways that you see in there's metal door frames there. Those metal door frames, you stand them up before you build the wall, and so a carpenter often does that. I've done a bunch of these where I basically had to go and put sheets of plywood in there in place of a door to kind of hold the whole door frame together, so that I can then screw some braces into the concrete on each side to kind of hold that thing in place for the bricklayers, the masons, so that they can go and install their masonry around it, and they put ties into the mortar as they go. So those steel frames are typically tied in as they build the wall. They are tying that into that frame, and so it's all about setting up that frame so it's perfectly level and plumb and everything, and kept checking it to make sure it doesn't move. But if you do it right and hold it in place, then it's fine. Now, there are cases where people will go cut a brand new door into an existing brick wall or block wall. Well, then those frames have to be installed a little differently. It's a little different process. Anyways, yeah, I got pictures of the brick ties here. The other thing you see down at the bottom is the black polyethylene sheeting. You can buy rolls of Visqueen. It's the brand name, of course, down here. That's the big brand name for plastic sheeting down here. But anyway, but you can buy rolls that are only 12, 18 inches wide, already pre-cut in long rows, maybe 1,000 feet of it. And you roll this stuff in here, and you lay it into the mortar joint as you're building the wall. And then it's laying down, and it becomes this flashing, kind of a inexpensive flashing. It's fairly durable, that you can lay your block is on it there, and then at the lower area, that lower concrete ledge, they have brick that'll be going there, and that's what these ties are sticking out for, so they can have brick ties. So I'll show you some other pictures here. There's some more brick ties that'll hold some brick in place, or block, or stone, and that sort of thing. And you can see they've still got a couple of braces on this thing. I guess it's held in place now long enough now that they got rid of the plywood so that they can walk through that door. But that's an example of that. Here's you can see the waterproofing on the wall, and then in this case they've got insulation because these are offices, and you can kind of see it peeking through that brick at the top of the wall and that corner of the brick up there too. So it's not uncommon to put insulation on the outside of a masonry wall, and then they'll get that hidden because they're going to be installing a brick wall in front of that with an airspace. Here's some joints where there are two pictures, and one on the right-hand side shows you the insulation there tucked in behind. Looks like it's kind of been moved out a little bit, but anyways, that's the idea. But meanwhile, the other thing I would point out is that brick and block walls, when they're large and long and tall, they've got to have control joints, just like concrete does. And so this is an example of a control joint. Any reinforcing in concrete bond beams and columns that are in a masonry wall, you will have that steel and that concrete continue. But on the outside, you'll have a control joint that doesn't get filled with mortar. Instead, it's a slot, like this empty slot that we see straight in front of us in the granite. They're doing their best to try to fill that with a high-grade caulking that looks as close to the same look as the mortar as possible. So that's what I've got, is a lot of pictures of examples of this stuff. In this building, they've got a lot of stainless steel brackets and posts and things. Anything made of steel on the outside is actually made of, well, most of it's stainless steel, not galvanized. Galvanized doesn't last as long as stainless steel, so those posts around each garage door bay, I think, are stainless steel, is what I remember. I took pictures during the day, and then nobody gave me any trouble. At night, I had a firefighter staring at me, trying to figure out what the heck I'm doing. I decided, when I'd taken all these pictures, I decided I might as well get the finished product at night, because it looked pretty nice at night, especially when they first finished it. Okay, so now we're going to move on to the last masonry chapter, dealing with concrete masonry wall construction. So I've talked a little bit about that already in both of these chapters. In our next stage is we're going to be looking at the wall construction in more details and some of the details of flashing, of how this all works. It's really important stuff. If you're ever running a masonry project, you really need to understand this stuff so you don't get in trouble and lawsuits and all that kind of stuff. Okay.